Yeah, so today, going to go over some of the more technical features of what JaamSim offers to people that want to develop their own discrete event simulation modeling libraries, some of the different versions of JaamSim that are delivered, and some of the consequences of how that delivery affects how you might use JaamSim. A bit of a high-level trip through how you might add your own custom code to JaamSim and develop your own libraries, and then a bit of a finger in the air, kind of possibilities for future directions of things we could add to the open source side of JaamSim, and any kind of questions or comments or even feature requests that people might have a burning need for that they think the JaamSim software should do. So, from Harry's talk yesterday, everyone knows JaamSim is a fairly fully featured and integrated discrete event simulation framework. It has at a base level a framework for controlling event flow and the time of simulation events. It provides a structure for building simulation objects and models and tying it all together with a configuration language to build your scenarios and do your studies. One of the things I really thought was important was that units are a first-class citizen throughout the software. So being able to express quantities in specific units is built throughout. It provides a model building environment to interactively build your models with a drag and drop framework, input editors, expression builders, kind of all the help you need in that environment to get your model up and running. And it provides a lot of tools for kind of introspection of your model, looking at the inputs and kind of properties and outputs of your simulation objects, looking at event execution, profiling your model to look for hotspots and performance issues, and even helping to kind of debug your model. Obviously, a lot of these models can be very complex with lots of moving parts, and trying to figure out where things are not as specified is really a key part of what makes the software useful. And then part of that is just visualizing your model, being able to visualize how the model is performing and is it actually doing what you expect it to do. So one of the things about JobSim is it does allow you to write your simulation code in two different styles, kind of what's normally called the process style or the event style. And you can mix and match those approaches freely as you build your own simulation objects. The process style does rely on switching between threads in the operating system, and this does have a bit higher overhead than the base events. And we'll come back to that later about some changes to that are coming. The current libraries that JaamSim ships in the open source version rely almost exclusively on the event style. So if you're reading the source code for the base open source JaamSim project, you'll see that we're almost exclusively using event style. I think except for the video recorder might be the last place where we actually use the process style, simply because it's not really performance critical. It does support conditional events. We've chosen in the current implementation to only evaluate those events whenever time is advancing. There are other choices that could be made in doing conditionals anytime certain state is changed, anytime an event is completed or scheduled. For the types of models we've built over time, we've generally found that conditional events at time advance is a pretty reasonable trade-off of efficiency versus functionality. Internally, time is always managed as an integer kind of tick. This generally makes time invariant as you get longer and longer into the simulation run and don't run into floating point precision issues, so that a 5-second delay at time 0 is still a 5-second delay at time 5 million. Just one of those pieces that we found early on, that making that time invariant behavior was really important, particularly for longer running models. And internally, there's a concept of the time of an event, and the priority used to schedule those events. And when an event is scheduled with the same time and same priority as another, whether you want that to go in effectively stack order or queue order to break that tie. And really, those are all the pieces that are required to schedule an event. Whenever events are actually running, that priority is not available, and whether it was scheduled FIFO or LIFO, is not available. It's really just whatever the current time is. As a kind of a just an example of what that would look like in the process style, when you're writing that code, you can essentially just put a wait in the middle of your code, and that will come back to keep executing that code after a certain amount of simulation time. So say you had some sort of maintenance loop going on, you could loop forever, do the maintenance, and then wait 5 ticks before doing that maintenance again. And that will loop forever during your simulation run. Every 5 ticks, it will call that do maintenance method and update the state. In the event style, generally you have some sort of entry point for doing all of your maintenance, and at the end of doing that maintenance, you say 5 ticks from now, execute that maintenance again, and it'll schedule that event on the future event stack and come in and run your maintenance thing. So this is a fairly simple example where effectively the maintenance loop doesn't have any real state that you're passing into it. So it's very easy just to schedule that by saying, oh, in 5 more ticks, do the maintenance again and schedule an event. Sometimes if you have a lot of temporary state or pieces that you need to keep track of locally, writing in the process style can actually be easier because you can just update that state directly in the method, and that same state will be there after 5 ticks when it wakes back up and continues executing that event. So the actual details of what's provided to the program, we're just going to do a high-level rundown of what API is actually provided. All of the timekeeping, all of the event handling, all of that management is provided by an object called the event manager, and it provides static methods that can be called from generally anywhere to access that event code. The one piece is if you are outside of the model context, it will always throw an error for you, and that's really just to assist the development of your model objects to make sure that it fails early when you're debugging and creating these models. And there are some calls that do occur from the user interface to get state of your model where you're not actually part of the model. And this is just we've decided on a fail fast method for this to really make it clear when you're in the model context and when you're in the user interface code, and being able to test that easily with do you have a current event manager allows you to very easily decide what of those two you're in. When you're actually managing time, again, part of that units throughout, the event manager provides the discrete time in ticks at all times, but also a value in seconds based on whatever time scale you decided on for what a tick represents. And really, if you're really down low writing your own simulations without using any of the other JaamSim UI code and writing just raw event handling, telling the event manager to resume event handling, and you can write all of that framework yourself without any of the 3D rendering, without any of the UI, if you wanted to write a very low-level event program. Most of the API is pretty consistent in that generally all of the process style API is start process and then waiting. So to actually start that new execution thread, you'll start process with some target, and that will run until it exits, and you can wait within that process to schedule it to resume later on. In the event style API, we've generally chosen schedule as the base unit that we talk about, just to differentiate when we're actually dealing with capturing a process that's waiting or just scheduling events. And we have a unified API for managing the future event list, whether they're event style or process style, to either kill them and remove them from the future event list, or to interrupt them and run them early. At a very high level, all JaamSim is really a list of future events that can be added to, where you have a lot of things looking to be scheduled. The next event will be taken off the list and made the current event. So say at the very beginning of a JaamSim model run, you'll have a start model event. And as you call the different pieces of API, whether you're scheduling a future event or waiting, it will then add events back to that future event list. From the current event, things like start process will effectively pause that execution and immediately jump into a new process until that process exits or until it waits, in which case you'll then return one back. Or if you interrupt a future event, it will pause what you're running and go run that event code in there. And once that code exits or waits again, it'll kind of unwind that list of execution until finally that current event exits or waits, and then it will grab the next future event off the list and start executing that code. Managing the event list is basically taking the next event off for execution, updating whatever the current time is, and running that code. Or if you're killing events that you don't want to execute because other things have changed in your model, it will remove that event without actually executing anything. So in a nutshell, it's fairly simple on the events side and looks pretty similar, I think, to a lot of simulation libraries and simulation software on managing events. The fact that it's event style and process style is handled all in the same environment is not particularly unique, but it is convenient that you can choose how to build your objects in the most natural way. And this kind of leads in some ways to how JaamSim is delivered at the moment, where we deliver kind of an all-in-one pre-built jar file that you can run with your version of Java that's installed, or we provide an executable wrapper that effectively does the work of looking up where your Java is installed and runs it in there. It is not particularly convenient at the moment to add your own custom code to the pre-built downloaded versions of JaamSim. It is possible through some environment variables to add your code to the class path and getting it looked up, but that is something we're trying to make a little easier. Right now, the easiest way to get your own code into JaamSim is to actually download the JaamSim source code project, build it yourself in an IDE like Eclipse, and start building your own Java code in there and building your own version of JaamSim with your code included. So a quick tour of the key pieces that you'll need to take care of to add your own code. We have a version shipped within the source code called demo entity, which is just a demonstration of a lot of the different pieces to add your own code to JaamSim. It's not exposed by default in the UI. It's purely for reference for people wanting to add their own objects. And the best place to start with would be something that extends display entity. Display entity really provides the full functionality to get your object into the user interface, allow it to be drag and dropped, configure with configuration code, visualize it in the 3D renderer, move it around the screen. There is a lower level object called entity that doesn't have any of that UI code or visualization built in, and can be useful for certain utility pieces for very specialized models or models where you really don't need to visualize certain parts of it. But I'd recommend starting with display entity. There's a lot of examples of how do you effectively add keywords that allow you to configure your object using the configuration file format to add interactive inputs using the input editor. Lots of examples in the source code on how to add the different types of inputs, how to add validation code if you have inputs that can only be within a certain range or that have certain requirements to give you checking and give you descriptive error messages when the inputs are outside of that range or invalid. There's a lot of expressions or numeric inputs or references to other types of entities in there. And generally, we've tried to make it as easy as possible to document the help text and an example of using each input that makes sense for your object. So this is where you can actually provide the descriptive text that appears on the tooltips in the UI, provides some help or feedback to the user that's trying to configure your object, and even give them an example of how to use it. Looking at how those inputs are set up, where you can start to say whether they're required inputs that if you create, drag and drop a new version of your entity, but don't have that input set, it will do some validation at the beginning of the run and let you know that certain inputs are required. And this is a way of kind of making more user-friendly objects in some ways, that they really let the user know what is required to use them properly and doesn't let you run the model without, certain things set where a default isn't possible. The entity framework itself provides two pretty key entry points that are common to all entities. And that's really this concept of early init. And that's really at the beginning of the model run, setting up all of the calculation state, setting up any kind of logical information that's needed to operate properly, and the startup method. And the startup method is really called to schedule any initial events that your entity needs to function properly, start any processes that are part of the functionality, depending on how you've coded that. And really, this is the entry point to the model run itself for your entity. So at the beginning of a model run, every entity will get one call to early init, and then every entity will get one call to startup. And this is really the entry point for your custom code or functionality that's in there. And you generally want to communicate it with other entities or different reporting or other state that you want to connect to other entities. And that's where the outputs come in. And the way we've implemented outputs in this case is to have methods that you can annotate. And one of the maybe oddities you notice here is that every one of these output methods actually takes a time in seconds that it comes in. And this is just recognizing that the outputs are used not just within the model run itself, but also appears in the UI. And the UI, when it is looking at the properties or outputs of an entity, is not running within the model. It's within the model system itself. It's passing a time in from the UI and saying, what was the value of this output at this time? And it's done this way so that the model is not coupled to the UI and can actually run ahead of where you are. And when you pause the model, there's really no inconsistency because things aren't updating. But if you want the model to run as fast as possible, you don't really want the model waiting to provide a consistent set of outputs for the UI, when really you would just prefer the model to run faster. The real-time button is there if you want to watch things at more human speed and see things changing in the UI. But there's not really an enforced consistency. The UI is what I'd say is more a best effort, whereas everything is enforced to be consistent within the model runtime. Once you've defined a new Java class representing your entity, hooking it up to the drag and drop menu, it's defined in a config file that you can load. You define an object type, which generally represents a type of entity that you can drag and drop. You say what the Java class name was, and this is the one piece in there where it will not find that Java class name unless the Java virtual machine running it can find your code. And that's where we're working on some better documentation for how to do that outside of a dedicated IDE, and trying to come up with a way of easily adding plugins so that people can develop their own libraries of code and put it next to a JaamSim download from the website and just have it be able to be picked up in there. There's a few organizational pieces where you can control kind of the palette that it appears under, just organizing it by theme. You can give it some default display models for the 3D visualization. Give it an icon to appear in that menu, a default size when it's drag and dropped, and a description that might appear in the tooltip to kind of communicate what it does. This isn't particularly convenient now. I'll say one more time. I fully recognize it's in some ways an interface only a programmer could love. And really, the best alternative right now is to build your own customized version of JaamSim with all of your code and any resources you need to do that. And that, in some ways, is fully supported by the license that JaamSim is released under the Apache 2 license, which allows you to even take that custom code and ship your own version of JaamSim without issue. So that's a pretty high level description of what is in JaamSim and how you might customize it with your own functionality. That leads to a bit of a discussion about where we, or at least where I'm interested in taking JaamSim over the kind of short to medium term. Definitely have gotten feedback that it would be really useful to have translations available for the help text and descriptions of the objects in other languages, and have what I call an example of that in progress right now with a possible French language version, taking that English text and just feeding it through the Google Translate API to produce kind of a language pack that can then be shipped and configured. It should be fairly easy to turn that on for other languages and possibly ship them by default, depending on the size of those translation files. Translating things directly in the user interface, like say under the file menu, under the tools menu, will take a little more work. Getting all of the help text for entities will actually be easier. Getting the examples will likely be easier in the short term. So we'll see what kind of interest people have in that kind of more localized version of JaamSim, or the ability to provide it in other languages. We've chosen to ship JaamSim as is, where it includes everything needed to run JaamSim except for a version of Java. There are ways we could deliver JaamSim with a single file that includes a version of Java in it. So it would literally be all you would need to download and would be entirely self-contained. This would likely require us to move forward to a different minimum version, as Java 8 would not really support this approach, but as we're shipping everything in one file, we'd be able to have full control over what Java version is contained in that. The download size would be significantly increased, probably on the order of 80 to 100 megabytes of additional size. Currently, the download size of JaamSim is about 15 megabytes, and frankly, it is fairly thin software. It doesn't take much to actually download it and play around with it. So go to the user forum and definitely could give your opinion on whether this would be helpful to your use case, or if that separate download of Java on your own machine is actually much of an impediment. Right now, we support Java all the way back to Java 8, which is getting very long on the tooth at this point, bordering on unsupported. And it provides an opportunity to maybe decide what minimum version of Java we should actually support back to. There are some advantages to moving forward to at least Java 21. So if we move forward to a new minimum version, I'd suggest we would move forward pretty significantly to something like Java 21 that offers virtual threads. And this is to solve a lot of that issue with the process style and the waiting style being less efficient than a pure event style. Virtual threads would allow us to essentially have only one operating system thread and manage the waiting threads within a purely Java environment. And this does have a proof of concept in the Java 21 branch on the GitHub repo for JaamSim if anyone wants to take a look what's in there. Um, there are some other language preview features in Java 21 which actually really help with some of the robustness of JaamSim, especially to uh, user code that may be in there, giving better feedback of when you're in the model code versus otherwise, and just making sure that it's always giving you an error as soon as possible with a way of fixing it. And on top of that, just making it easier to not just configure JaamSim using the configuration language, which I think we have a pretty good solution for at this point, but really making it easier for people to plug in their own libraries of code for their own specific industries, use cases, and needs. Yeah, so that was a pretty rapid tour of what's available in there, and I'm really happy to take any questions or comments or just any discussion. In particular, I'm really interested, has anyone tried to add their own objects to JaamSim, and have you run into any deal breakers that made it really, really hard to either to get started or to accomplish what you wanted to accomplish? Thanks a lot, everybody.
Thank you very much, Harvey. You can type your question in the chat, or you can probably just unmute if you have any questions for Harvey.
I would also accept feature requests.
All right, we got a question in the chat. Justin asked, would it be possible to add functionality with a native DLL, or is it strictly via Java?
Yeah, no, it's you can use JNI or some of the Java method handle functionality that has come in more recent Java versions that I think would all be on call it your side of the code base. So I don't think JaamSim at this point really would have to do anything to support that. It would the full functionality of interoperability with native code is available in Java, and you can use that freely in your entity to say implement external calculations, maybe get feedback from external running processes. That's definitely all available to you if you're writing custom code.
All right, thank you. Martina Kramer asked, how does a tick mechanism combined with fluid handling?
I think in some ways that I don't know if you were around for Harry's talk yesterday. It really depends on the design of how you're modeling that fluid, whether you're modeling it as kind of small bundles of fluid and updating those levels every regular time interval, or doing a more continuous calculation. So I'd say the whole reason it's called discrete event simulation is while you're running your code to modify the state of the model or modify the state of the simulation, time is not advancing. It's always at a discrete time, and you change the state of the model and then advance time after that. So you could write your fluid handling library in a continuous manner, calculating change over time, but only making those calculations periodically, or it would really depend how you've structured your model.
All right. So I'm going to get back to some of the other questions, but Mark asked, can you describe how the simulation clock interacts with JOGL for displaying frames?
Sure. So I think I've mentioned previously that one of the design decisions we made was that the simulation will not wait for the user interface to provide, say, a fully consistent update. So when you're running a JaamSim model, the user interface is effectively uh, rapidly updating as fast as it can. And part of that is the 3D rendering, kind of collecting all the state of the simulation, collecting all of the outputs, the position, and things like that. But it does that effectively asynchronously with the model. So it runs over all the entities in the model, collects a picture of their state, looks at their display models and how that state is supposed to be translated into the 3D environment, and then produces a frame, and then goes back, runs over the model again, collecting new state and drawing another frame. So it is possible if you're running not in real-time mode, just as fast as possible, you may see some inconsistent frames where the model was running so quickly that it collected, the first 100 entities, collected all of their state, and a few more events happened while it was doing that. And when it looked at the state of the next 100 entities, time has moved forward, and it's not a consistent frame. And you may even get some errors where it ran into inconsistent state where the code didn't expect that. We kind of allow the user interface to be fragile in that way and just say, oh well, that frame wasn't consistent. I'll try again on the next frame and move on. When you are doing things like recording a video, we effectively have a way of saying, oh no, in this case, the consistency of the output is actually important for this, and is not just trying to give the most frames rendered to give you a picture of it. We actually want to reflect a video that's consistent every time, and so that actually will stop the event processing, collect all information, render a frame, and then move forward to the next frame. So there is a way of, by default, we make it inconsistent, but as fast as possible for actually running the model. If you're running in real time, that tends to be more at human speed, and the renderer is more than able to put a lot of frames together and give you something consistent.
All right. Christina asked a question that's getting some attention. She comments, I'm a JaamSim beginner, and I have not looked into creating custom code for my model yet. One problem I've run into is the limited number of distribution options in JaamSim. Does this mean through custom code I could add any distributions I want to the model?
Yeah, that's exactly what it means. You could add your own distributions. I would take some issue with the description of the limited number of distributions in JaamSim. I'd be curious of what distribution is not in JaamSim that you would be using commonly, as there's a pretty comprehensive set of distributions already in there. Not to say that it's all of them by any means, but I'm always happy to take requests on the forum if there's really a distribution that has an implementation that is available, and we can get it included. That's a pretty easy thing to add, and not a bad first task for someone who might be looking to participate in development of JaamSim.
All right. Anthony Earl asked, does the user interface catch up when it reaches the pause time?
Yes, it does. It will force one more frame regardless when it gets to that pause time to ensure that that final image is consistent on the screen.
So I'm going to go back. Looks like there was a feature request from Craig. I believe he presented yesterday. I think his talk was on modeling underground mines. He mentioned it would be good to have a fuel burn for a vehicle. And I see Harry's turned on his screen. So
You want to take that one, Harry?
Yeah, Craig. It would be possible to do that. It would have to require some relationship between some equations for fuel consumption as a function of acceleration, power. There'd have to be some sort of concept of grade built into the model. So it's certainly doable. It just needs the vehicle object just needs some more information to do those calculations. So let's exchange some emails on that offline and see what we can do.
All right.
Harry, I had a question on that as well. Like, is that already doable through what what the vehicle has and its expressions, or would you actually need to add to the code base to accomplish fuel burn?
Yeah, no, there's no information required. The expression would need some information which isn't available, or it isn't even calculated. So for a ship, I mean, basically there has to be a relationship between acceleration and speed and power consumption, and then
Hmm.
a relationship between power and fuel consumption. So the vehicle needs to have some more information to do those calculations, but it's certainly doable.
One of the things that I'm thinking of, a potential pitfall, is that what happens if a vehicle or a cargo vehicle runs out of fuel? Does it just stop and then block the pathway? Or, do you say once you get down to 5% fuel remaining, you know, you have some sort of, refueling step or
Yeah,
something?
I don't think you'd want to model the out of fuel situation because you would never build a system that allowed vehicles to run out of fuel. You would assume they had always had adequate fuel, and you're just calculating. Okay, I've just traveled from Vancouver to Hong Kong. How much marine fuel did I use up in that trip? Or in case of an underground mine. I've just hauled 100 tons from the bottom of the mine up to the surface. How much fuel did my truck consume?
Um, so some good comments based on some of the things we've been discussing are in the thread. I'm going to ask Mark's question. It looks like discrete event logic uses Java threading primitives. What was the motivation for this rather than other packages where each replication is meant to be run embarrassingly parallel to its own thread? I could be totally wrong about what's happening in the Java code.
Effectively, JaamSim does run in the embarrassingly parallel. Essentially, each replication is running in its own thread in a fully parallelized fashion. Now, when you run in your model that has a process-based implementation, you're capturing additional threads to manage some of that state. That additional overhead goes away with the virtual threads in Java 21. And that's really, I'd say, the number one scalability issue in the current JaamSim implementation is the ability to capture a number of process-based loops at a time, where I'd say you're limited to a low number of thousands of outstanding kind of future events that are using the process-based, as opposed to millions, or I think even tens of millions on the event-based one, just based on the number of operating system threads that can actually effectively be utilized. That goes away with virtual threads as of Java 21, and that's really the one, I'd say, fundamental limiting factor to JaamSim's scalability is that use of direct threading to implement the process code. But we've been using that method all the way since Java 4 back in the early 2000s, and you can still scale models remarkably far even with that limitation. But we have well, not just beyond a proof of concept, we have effectively an implementation that we can drop in, assuming that the minimum version we support is Java 21, and can scale that almost to the size of system memory on the machine you're running on. So as we move forward and software gets a little older and a little more unsupported, we'll eventually change that implementation unconditionally to the virtual threads one.
All right. We are about 10 minutes over our allotted time. So I'm going to perhaps ask one more quick question. Osama asked, is there any online tutorials where we can follow along and perhaps get some greater skills?
Yeah, I mean there is a programming manual that we're just starting to really consider now as how that might better support people moving forward. And I know there's a lot of interest into some more bite-sized tutorials of just specific implementations of your own entities within JaamSim, and whether or not those are more like a YouTube tutorial or kind of a more focused task-based. Happy to get feedback on what would be most useful to people, and what, how people would like to be supported on that. Feel free to go to the forum with your ideas on how we might be able to communicate that better.
All right. Well, thank you very much, Harvey. I encourage anyone who has a question or a comment to get in touch with Harvey and Harry. I see Jason's got his hand raised.
Yeah. Sorry. I mean, I had a feature request, but I think we should move on. But I was going to ask, Harvey, are you going to be around at the break? Just in case this is a good discussion. So will you be available later today if at one of the breaks if people want to still ask questions?
Yeah, no, I'll definitely be around for the breaks today. I was a bit unfortunately engaged yesterday, so I wasn't able to attend nearly as much as I wanted to, but I'll be around quite a bit today.